Alright, let's look at Theorem 1. A diagonal of a parallelogram divides the parallelogram into two congruent triangles. Alright, so let's look at this picture. Parallelogram A, B, C, D, and I'll use the diagonal segment AC. We could have used segment BD, which is the same thing, but for now I'm going to pick on segment AC. Right? Then this diagonal AC will divide these two congruent triangles. Right? So let's prove that. Alright, so line 1, AB, segment AB is parallel to segment CD. So AB and CD are parallel, right? Because it's by the definition of parallelogram. And AD is parallel to BC. So we have that. All right. So let's say 3. All right. Since we know that AB, let's look at here. AB is parallel to CD, right? We can use the Z property, right? So I'm using the fact that AB is parallel to CD, and also along with the Z property, to show that angle here is congruent to angle there, right? So angle BAC is congruent to angle DCA, right? We got that. And line 4, and we can use a reflexivity, so I'm going to just write the reflexivity to show that the segment AC is congruent to itself, segment AC, right? So we have that. All right. Then we look at this using the fact that the AD, maybe I'll use that. AD is parallel to BC, right? So I'm using line 2, right? Line 2. And then we use the Z property again, so Z looks like this, right? Z property to say line 5, we know that the angle, maybe I use a different color, angle here is congruent to angle there, right? So that would be angle ACB is congruent to angle CAD, right? Then 6, and this is all we need because we have an angle side angle. So we know that therefore triangle ABC is congruent to triangle ABC. So CDA. This is by angle side angle, right? So angle comes from line 3, side comes from line 4, and angle comes from line 5, right? So we could have this, we could establish the congruence between these two triangles, right? That's that. And there's some note here in a parallelogram. These are corollary of Theorem 1. And here it says that in a parallelogram, opposite sides are congruent, right? This is pretty easy to see. Once you have two congruent triangles, and we know that the opposite sides, so this actually corresponds to that guy, right? Then we know that this corresponds to that guy. So those are opposite sides. Those are congruent because of congruent corresponding parts of congruent figures, right? And the opposite angles are congruent. This is same thing with the size. You can see that here, this angle right here corresponds to that angle, right? So again, this is, and also this plus that, and the red 2 and the red 1, so those two together is a congruent. So again, CP, CF will justify those two guys, right? The last guy, adjacent angles are supplementary. So we're talking about the angle here, this guy, and the angle here, right? But this is coming from actually a C property, and you can probably see the C property by looking at it like this. Alright, so by C property, these angles are supplementary. So we have that. So oops, maybe I should that. And the justification, this is just a C property. Alright, that's it. I hope that this was clear.